to the charger, so we are no longer running on fumes. Let's go. Now let's look at dynamic programming, right? Let's clean up this workspace. Ooh. We like that part. Let's see. Let's get rid of this. Cool. So if you have seen any dynamic programming problems before, you know it's got something to do with tables. Now, I mean, it doesn't really have anything to do with tables per se, but it has things to do with memory, right? And one of the most efficient ways we can represent memory is sequentially with tables, right? This we're doing is bottom up dynamic programming, right? We're still asking the same question, right? What happens when we include the new bill, right? And what happens when we exclude the new bill, right? So let's, oh yeah, what I've done here is just basically write out, what's it called? Our amounts as rising all the way from 0 to 5, right? Yep, so that we can build the problem up sequentially. It'll become very clear why I've done that very soon. So from before we had $1 bill. We had $1 bill, $2 bill, and $5 bill, right? Here I should say it'll become a little more clear that we are not really looking at only the $2 bill, right? We're looking at what happens where 2 and 1, right? So I'll just make these guys as lists, right? So 5, 2, and 1, right? So let's say this guy, right? Oh, that was awful. Yeah, let's say this guy, right? What does this row comma column represent? This, let's call this, I don't know, let's call this dynamic programming table, DPT, right? So DPT at 3, comma 2, comma 1, right? So 3 is this guy and 2, comma 1 is this guy. So what this represents is how many ways we can represent 3 using $2 and $1, right? That's what this represents. Right, so now we have some idea what this table means. Let's go ahead and fill values in it, right? Let's erase some of this. We have explained to ourselves what the DPT notation means, dynamic programming table. All right, so now let's look at amount 0, right? How many ways can we represent 0 using $1, just $1 bill? Well, we can't represent it, right? Because 0 is no amount. So there's one way of representing it, which is to do nothing, right? That's 1. Now you may be wondering why we have 1 here instead of 0. It'll become very clear as we are coding it out, but a permutation and combinatorics explanation would be, how many ways of doing nothing? It's still one way, right? How many ways of representing 2 and representing 0 using 2 and $1 and 1? 1. How many ways of representing 0 using 5, 2, and 1? 1, right? Now, how many ways of representing 1 using 1? That's 1. How many ways of representing 2 using 1? That's also 1. How many ways of representing 3 using only ones? That is, 1, 1, and 1. So, little 1. Oh my God. If only had $1 for every time I said 1 in this video, right? Right. So how many ways of representing 5 using 1? That's again 1. All right. Now, how many ways can we represent 1 using $2 and $1, right? Let's look at the question again, right? So we're still looking at what happens when we exclude the new bill, right? And include the new bill. So let's say our case is amount equals 1 and new bill equals 2, right? Amount minus new bill. Oh, let's just move this guy to the left so we have some more room to work with. All right. So amount minus new bill, right? If this guy, so amount is 1 minus 2, right? That's minus 1. We're looking at the scenario that from before when we owe people money, right? We don't want to do this. So what do we do in this scenario, right? We just exclude the $2 bill, right? And then we default to like a representing amount using only one, right? So we have 2 and 1, right? We are trying to fill this spot, right? We look at what happens when we use 2, right? So 1 minus 2 is minus 1. We don't want that, right? And then when and then what do? We say how many ways can we represent 1, right? Using only the 1, right? So we introduced a 2 here, right? We introduced let's change colors real quick. We introduced 2 here, right? Now we say 2 doesn't work for us, right? We start owing people money when we have 2. So we go left, right? We say, how many ways can I represent 1 using 1 alone, right? So we say excluding 2, we have 1 way, and including, right? Including, we have 0 ways, right? Because it doesn't make sense. This is this scenario, right? When our remaining amount goes to, less than 0. We owe people money. We don't like that. So that's out of the picture, right? Let's clean this up. So, and we would add 1 plus 0, right? Which would give us 1. I think that should make sense. If not, you can, as usual, rewind this or leave me questions in the comments. Let's go. All right. So we have 1, right? Let's erase this very carefully. All right. So we have 1 here, right? By the same logic, now we introduce 5, right? So we introduce the $5 bill. Doesn't make sense, right? Because like 1 minus 5 minus 4, we start owing people money, right? We are like, all right, we don't like that. Let's go straight to what's it called? Let's go straight to just not counting that case, right? So when we include 5, right? Same thing as before. Include the new bill. Include 5. We get 0 ways. Plus, what happens when we exclude 5? When we exclude 5, we're left with 2 and 1, right? Now the question becomes dpt of 1, right? How many ways can we represent 1 using 2 and 1, right? What do? We basically say how many ways are representing 1 using 2 and 1. So we get this guy, right? So we can put a 1 here, right? Because it is 0 plus this value of 1, right? 0 plus 1 equals 1, right? So what does it, I think we are starting to see some rules emerging, right? And we like rules in programming, right? Because you can, if you have a rule, you can just tell the program explicitly to do something and it'll do it for you. So that's what we want to do, right? So we have some concept of a rule emerging, which is, let's see, rules. First rule is if amount, right, minus the new bill, right? New bill, in which case it was 5, right? If that is less than 0, right? If that is less than 0, we default to not counting that guy, right? We default to like in every scenario when we can't use the new bill, we basically default to excluding it, right? So we'll say if amount is less than 0, we will default to excluding. All right. Default to excluding, right? If it is more than, right? If amount minus new bill is greater than or equal to, let's just take 0 into the case also, right? We would default to counting the excluded case plus counting the included case, right? Let's look at fill out the table more, and this will become more clear. All right. Right. So now we have the our amount changes to 2, right? And this is no longer 0. I mean, no longer -1, but 0, right? So what do we say when this is greater than or equal to 0? What do? We got to look at both excluding the new bill and including the new bill, right? So dpt of 2 using 2 and 1, right? And then we said what happens when we include the 2, right? And we exclude the 2, right? So if we include the 2, we just say 2 minus 2, 0, right? So that is 1 multiplied by, and how many ways can we represent the remaining amount, which is 0 in our case? We are lucky, right? This is 0. We know trivially that's just 1, right? But just to formalize it, we can say this becomes dpt of remaining, right? Of remaining amount using the 2 and 1, right? When we include it. The reason I'm writing this out explicitly is so that we can take advantage of the table, even though we know trivially, that how many ways can we represent 0? That's just 1, right? So dpt of remaining, let's see, 0, it becomes dpt 0 using 2 and 1, right? So we get a lock here. So we say 1 multiplied by 1, right? Plus, what happens when we exclude the 2, right? We exclude the 2, so exclude 2 meaning the new $2 bill. So this becomes dpt of representing 2 using just the 1, right? Since we're excluding the $2 bill. So what is that? dpt of 2 using only 1, right? So it becomes this case. Oh, that looks horrible. Let's just erase all this and make it a little nicer. Oh. All right. Right? Plus 1, which is equal to 2. Right? Sweet. Now, let's see the case when our amount is 5. Oh, sorry. When we include the new bill of 5, our amount is still 2, right? This guy. Let's erase this. All right. Right, so our new bill is 5, right? Amount minus 5 is minus 3. What do we say from our rules? When amount minus new bill remaining, when that is less than 0, we only have to do the excluding case, right? So this becomes exclude only, right? Which is dpt of 2 using, remember this is excluding the 5, right? So let's just leave that empty, 2 and 1, which is what? This guy, right? dpt of 2, right? And this guy, right? Makes sense, right? 2 using 2 and 1. This is what it defaults to, right? All right. So we already calculated the value, that is 2. All right, now let's look at what happens. Now things will get a little more interesting. I think after this scenario, like we have pretty much, we could start coding. We could, formalize it, but let's go all the way just to, just for sake of completeness. Right, so now our amount becomes 3, right? And our new bill in question, so we're trying to fill this box. New bill in question is 2, right? Amount minus bill is 1, right? So what do we do? When amount minus bill is a positive or 0 number, we count the excluded case, right? And count the included case. Let's see. So let's start with including the 3, right? So including the 2, I'm sorry. So when we include the $2 bill, we are left with, so we have $2 bill position filled, right? Now we are left with $1, right? We have $1 amount remaining still. That is dpt of 1 using 2 and 1, right? Because the question we were asking was, how can we represent amount 3 using 2 and 1? We say, all right, since we want to represent 3, let's just use the second bill right away, right? That's one spot taken. Now, once we already give $2 away, we are left with $1, right? From the amount 3. How many ways can we represent 1, right? This is where the 1 comes from. How many ways can we represent 1 using 2 and 1? We have already answered that question, right? How many ways can we represent 1 using 2 and 1? That is 1, right? So dpt that is 1, right? All right. So right now we have calculated what happens when we include 2, right? Include the 2. We have one way, right? Which is we include the $2 bill, right? We include the $2 bill. One way of including the $2 bill, multiply by how many ways of representing the remaining amount, which is 1 using 2 and 1. So 1 multiplied by 1 gives us 1. That is this guy, right? Now we got to see how many ways can we represent 3, right? By excluding 2, right? By excluding the new bill, right? So 3, by excluding the $2 bill, right? This becomes dpt of 3, right? Excluding the $2 bill, so that we just have 1, right? We have already calculated this, right? dpt 3, 1, right? Which is 1. Right now, since this is an OR, we add these guys, right? And we arrive at 2, right? 1 plus 1 equals 2. Cool. By the same token, you can go through this whole calculation again for 5, right? Let's just do it. Why not? Right? How can we represent the amount 5? Ooh, that looks nasty. Right, 5 using whoops, how can we represent 3 using the new bill 5, right? Right, so 3 minus 5, that's minus 2. We exclude, we default to the exclusion case, so that becomes dpt of 3 using excluded, right? So only 2 and 1, which is this guy we calculated. So 2. Sweet. So we already know some rules are emerging, right? That's fun. Now, this becomes what to do for scenario when our amount is 4, right? And new bill is 2. Amount is 4, new bill is 2. Right, amount 4, new bill 2, amount minus new bill, that is 2, right? So this becomes, what's it called? This becomes the one way of representing the 2, right? One way of representing the 2 multiplied by dbt of, what's it called? 2, because 2 is remaining, right? Of 2 using like 1 and 2, right? Because this is the inclusion case, right? So dpt 2 using 1 and 2, right? That is 2. So 1 multiplied by 2, 2. Cool. Now let's go ahead, exclude. This was the include case. Now exclude the 2. We have dbt of oh man, that was bad. This is dbt 4. Yep, dbt 4 excluding the 2. That is just this guy of 4 excluding the 2. Only 1 is in consideration, so that is 1. So what do we have? We have 2 plus 1, 3. By the same token, same thing as we did before, since 4 minus 5 is minus 1, we go ahead and collect this guy, right? That isn't quite clear. You can rewind the video a little bit to see why that happens, or leave it in the comments. All right, so now we are very, very close to answering our final question, right? Which is, how many ways can we represent the amount 5 using 5, 2, and 1? All right, let's clean this area real quick. Sweet. So now we have amount 5. Our new bill, right, is 2, right? So 5 minus 2, that is 3. So this is dbt 3 using, oh, let me just make sure we have it very, very clear. This is the, oh, what the, all right. This is the include case, right? Because this is include, that is why we have, 2 and 1, right? Plus dbt of 3 without, oh my god, why do you keep saying, oh yeah, sorry. Plus dpt of 5 excluding the 2, right? dpt of 5 excluding the 2 points to this guy, which is 1. And then dpt 3, right? 3 represented using 2 and 1. 3 representing using 2 and 1. So that is 2. 2 plus 1 equals 3, right? Now, our final question, right? The moment we've been waiting for through this whole video. Oof. All right. Right, let's take a nicer color for this, or, I'm out of colors, never mind. All right, now, amount 5, right? Using the new bill 5, right? So we have a fancy new bill 5. So back to the drawing board, right? Amount minus new bill 5, which is equal to 0. Since this falls into, greater than equal to 0 case, we count the excluded case plus count the included case. Let's start with the excluded case. So dpt of 5, right? Excluding the $5 bill, meaning we have only 2 and 1, right? So that is 3, right? dpt of 5, 2 and 1, right? It points to this guy. And then including the 5. So when we have the 5 included, we are left, so 5 is the amount, 5 is the bill we include. We have 0 remaining, right? So dpt 0 using 5, 2, and 1, right? Which is 1, right? We add these two and we get a 4. Sweet. We have 4. Let's make sure this is in fact, what we got by manually counting these numbers, right? We have 1, 2, 3, and 4, right? We get 4. Now, since we did all this, good hard work on the whiteboard, let's translate that into code real quick. So let's do that, right? Let's get rid of our recursive solution. Right, let's start with a fresh new drawing board. Fresh new code. Let's put pass, right? Get rid of the recursion case. All right. Right, now let's start, right? Let's say if amount is, this we're just thinking of the corner cases, right? If amount is 0 or it's less than 0, we just return, there's 0 ways of counting this, 0 ways of counting, 0 ways of counting a amount of 0, or we owe you meaning negative numbers using bills, right? Because we don't like owing people. All right. Sweet. Now we went ahead and made this dpt thing, right? We did the dpt table. We want to find a way to translate that into we can't just, we need a way to let Python know this is what we're thinking, this is what we want. So let's see, our amount was 5, right? And we started here from 0. So 0, 1, 2, 3, 4, 5, right? Since we are counting the 0 case also, how many is that, right? That is, a quick aside, right? This guy and this guy will not be part of our, our code table, these were just labels we used for our understanding's sake. This is what we are really interested in, right? This is what we want to code up. So let's think along those lines. So let me just erase that. Right? So what do we have? We have 1, 2, 3, 4, 5, 6. What is it? What is 6 here? 6 is amount, right? Amount in question plus 1. Why plus 1? Because we wanted the 0 case, right? And then what is this thing, right? The number of columns. Number of columns is just basically number of bills we have, right? That's sweet. So we need amount plus 1 rows and number of bill columns. All right, that's good. So let's see. Row len is what was the number of rows again? That was amount plus 1. Cool. And column len is, how much was that? That was just length of bills. Why length of? Because it's an array, right? So I'm going to use a little fancy Python notation. Like I think this should be clear enough. If not, you can just Google, how does this Python notation works, or ask GPT or something. It's like very, very simple. So for I in range, all right, range, so row len, right? Row len is amount plus 1, right? And then how many, what's it called? Columns do we want? We want 4 j in range, whoops. Range, what is this? We need column len, right? All right, column len. Oh my god. All right, there we go. Yeah, so we know what these guys are, right? We can just put these variables in. I think it looks fancier that way. Right. So range is 0 to length of bills, right? Cool. And then I goes from 0 to amount plus 1, right? Cool. Now let's make sure we did this thing properly, right? We can just go ahead and print DPT real quick. Let's make sure, we didn't mess things up. Oh, all right. So what is this? We have 1, 2, 3 columns, right? Which is 1. Oh, where's my? All right, let's see. Oh god, notepad got stuck. All right. We have 1, 2, 3 columns. It's gonna start up real quick. Right? Yep. 1, 2, 3 columns, right? 1, 2, 3 columns. And we need 6 rows, right? 1, 2, 3, 4, 5, 6. Corresponding to amount plus 1, right? Let's make sure that is in fact the case. So 1, 2, 3, 4, 5, 6. So our board is initialized. It looks good. DPT table looks good. I put in ones here because, for the 0th case, we want ones just to, just to be a little redundant, right? Because when we have no bills to represent a certain amount, we say we can't, right? To represent amount 0. So we say we have one way of doing it. All right, so let's do this. Now we got to traverse through this whole board, right? For I in range, this is our good old columns. I'm sorry, our rows. 0 to length of bills, right? And then for j in range 0 to length of 0 to length of bills is our columns, and row count is amount plus 1. All right, pass. Cool. So at this stage, right, what does this correspond to? This corresponds to going through every one of these columns, right? And we say, what's the amount at that stage? Amount is given by value of I, right? Because it goes from 0 all the way to amount plus 1, right? 0 all the way to amount plus 1. In Python, this guy is not inclusive, right? The upper bound is not inclusive, only the lower bound is. That's why 0 is included. 6, however, will not be included, so it'll be 5 inclusive, right? Because this is Python. If you don't believe me, just, just have a quick check for I in range 0 to 6, right? Let's do print I, right? So 0, 1, 2, 3, 4, 5, right? Right. Sweet. Let's uncomment this real quick. All right. Right, so our amount in question is equal to I. Right? Now, our bills, right? What bill are we playing with? That bill is the jth member of the bills array, right? Now, let's look at the rules we made, right? What was the rule? If amount minus new bill, let's call that REM, right? Remaining. If that is less than 0, right? We do something. If it is greater than 0, we do something else, right? That's if else. Good old coding if else, right? So, let's see. Rem is equal to amount. What did I do? Oh, yeah. Since we are already using the amount variable up top, we should, use a new variable. So AMT minus bill. This is the amount in question minus bill. Bill is the new bill we're using, right? Now, if rem is less than 0, we do something, right? Else, we do something else. Right. Now let's figure out what the something is, right? So this is the case when we are excluding the new bill, right? So let's say we were playing with 5, right? What would we do? We would say dpt of amount, right? Let's say we're looking at this case, dpt of amount, and excluding the new bill, right? So let's say this is the jth index. What are we saying? We exclude the 5, meaning go 1 back. So that would be j minus 1, right? Because we're excluding just the new bill. So what would we do? We would say dpt at ij, right? The dpt value at this guy, ij, right? dpt at ij would be the excluded guy, right? It would be this guy, right? And how do we arrive at that? We arrive at that by saying j minus 1, right? So we say dpt of still amount 5, right? Because we still say amount 5, and then we go 1 back. So that is j minus 1, right? Otherwise, what do? We do something plus something, right? This scenario. Something plus something. What is this? This is the excluded case. We already have the excluded case, right? Which is dpt of amount, just not considering the new bill. So we go 1 back. We already know what the excluded case is. So dpt of, let's see, something is the, is the excluded case, right? Excluded case is just this guy. We already calculated that from before. Sweet. Now we will say, when we include the case, right? Count included. Now, what did we do when we include the, let's say this scenario, right? Okay, let's say this scenario again. Actually, this would be the best to explain. Let's say this scenario, right? dpt ij is 4 using, this is include, right? Mind you, we're looking at this guy, right? Include using $2 and $1, right? So this is our new dollar, right? The new bill we want to consider. 4 minus 2, we're left with 2, right? We use the $2 bill in this position. There's one way of using that. We multiply that by dpt of 2, right? Using 2 and 1. What is 2 here? 2 is the remainder, right? 2 is amount minus bill, right? We already calculated amount minus bill to be rem. So we say dpt of 2 including 2 and 1. So we can say dpt, this is the plus something, right? dpt of remainder at j, right? Because this is, we are still including the $2 bill, right? Now, where do we assign this guy? We assign this guy to ij. dpt at ij. All right. Let's see. This should work, but you know, golden rule of programming. Nothing ever works at the first go, so let's see. Fingers crossed. So we should expect to see 4. Let's see what happens. Okay, error. That's okay. We can, you know, that's what debugging is all about. Cannot access local variable bill where it is not associated with a value. Oh, because our array's name is bills. Sweet. Okay, execution successful. We get none, right? Let's see. Let's make sure to. Oh, what do we want to return? We didn't return anything. So we want to return dpt. We want to return this guy, right? The last index, right? In Python, you know, because it's not nasty Java, Python is just dpt -1 -1, right? Oh, let's make sure notation is right. This is how we return the last guy. Now, just for the sake of clarity, let's just print all our dpts, right? This will serve as a redundancy step to make sure we're not making any mistakes, right? Oh, so we got 13 here. So that means we're clearly overcounting something, right? Let's see. So here, DPT represents the array, not the, yeah, the 2D array, the table we made, right? This first row corresponds to, let me highlight it. First row corresponds to when our amount is 0, right? Amount is 0. So we expect the full table, right? This is outputting the full table. Full table to be just ones, right? Let's see. Just ones. That's good news. Now, the second time, right? We should not be expecting this to be just twos here, right? What were we expecting? We were expecting this guy to be 1. So why did that happen? Let's see. So I normally would have, just used the debugger since we are using an online programming environment. I don't think we have a debugger here. So let's think through this logically, but I highly recommend using a debugger. Debugger is definitely the way to go. Let's see. So here, this is getting counted here itself, right? That means that when j, right, ij, when j is 0, right, meaning this scenario, when j is 0, it's still going through and adding stuff, which we don't want, right? I think when j is here, it's still going into this case. So when j is 0, remember we just straight up filled this table. We didn't do anything, right? So we should do these cases only when j is greater than 0, right? Okay, that printed 4. Now, the only reason I was able to come up with this quickly is because, like I have some, like I had worked through the solution before, explained to you guys on video. So I think, I had already encountered the error j greater than 0. But like the way I found it out originally was using a debugger. And I cannot stress this enough. Using a debugger is a real, fantastic way to do programming. Like you don't need to guess anything. Like I cannot emphasize enough how important it is to use a debugger. So, right, so that was sprinting. Let's see. Now we should just get 4, which we do. So that concludes this tutorial on bottom programming. Let me know if you want more explanations. All right. Bye-bye.